Hey everyone, welcome back to the Zach Moore Podcast. Today we're taking a deep dive into one of the most fascinating planets in our solar system, Venus. Now, this is not my typical style of video. Obviously, this is not a podcast, but this is a topic I have been preparing for a few weeks. This fascination with the planet started months back when I started using the small telescope I have at home to look at planets, including Venus. Now, on my podcast, I have talked previously about Venus and have always wondered what could have caused Venus to be our closest neighbor, yet not one of the planets most traveled to, since it is quite easy to get there, relatively speaking. Venus has been called Earth's sister planet, a potential past Earth-like world, and even a candidate for extraterrestrial life. But it's also one of the most extreme and hellish planets we've ever explored. From ancient civilizations to modern space missions, Venus has been a mystery that humans have been trying to solve for centuries. Today, we're going to break down the history of our understanding of Venus, what makes it so unique, and the incredible missions sent by both the United States and the Soviet Union to study it. So, let's start at the beginning. Venus is one of the brightest objects in our night sky. Because of this, it's been observed by humans for thousands of years. Ancient civilizations like the Babylonians, Egyptians, Greeks, and Mayans were all fascinated by it. Many believed it was two separate objects, one appearing in the morning, which they called the morning star, and another appearing in the evening star. The ancient Greeks eventually realized that these were the same object, and they named it after their goddess of love and beauty, Aphrodite. The Romans later renamed it Venus. The planet was named after her because of its bright and striking appearance in the sky, which was associated with beauty and radiance. Since Venus is the third brightest object in the sky after the sun and moon, ancient civilizations often linked it to deities of love and femininity. The Romans continued this pattern of naming planets after their gods, a practice inherited from the Greeks but formalized in Latin. This is why we have Mercury, named after Hermes, Mars, named after Ares, Jupiter after Zeus, and so on. Fast forward to the 1600s, and Galileo Galilei was one of the first people to observe Venus through a telescope. He discovered that Venus had phases, just like the moon. This was one of the key observations that helped prove that planets orbit the sun rather than the Earth. Before we had spacecraft, many scientists believe Venus might have been a tropical world, maybe covered in thick jungles or oceans. Some even speculated about life formed beneath its clouds. But as technology advanced, we soon realized Venus was something very different and much more hostile. So why is Venus so unique? Well, for starters, it's often called Earth's sister planet because it's almost the same size, has a similar mass, and is the closest planet to us in the universe. However, that's where the similarities end. Venus is actually one of the most extreme, inhospitable planets we have ever studied. Its surface temperature averages around 900 degrees Fahrenheit, which is hotter than the surface of Mercury, even though Mercury is closer to the sun. Venus has an incredibly thick atmosphere made mostly of carbon dioxide with clouds of sulfuric acid. This creates a massive greenhouse effect, trapping heat and making Venus the hottest planet in our solar system. Sulfuric acid is a highly corrosive and dense liquid that is commonly found in industrial applications here on Earth, such as batteries and chemical manufacturing. It is a strong acid that can cause severe burns and reacts violently with water. On Venus, sulfuric acid is a major component of the thick, toxic clouds that completely envelop the planet. This is due to the volcanic activity on Venus, which releases large amounts of sulfur dioxide into the atmosphere. When sulfur dioxide reacts with water vapor and oxygen in the upper atmosphere, it forms sulfuric acid droplets. Now, why is sulfuric acid in Venus's atmosphere? Well, volcanic outgassing. Venus likely has active or at least recent volcanic activity, continuously releasing sulfur dioxide into the air. Lack of a water cycle. Unlike Earth, Venus doesn't have liquid water to neutralize sulfur compounds. Instead, the sulfur dioxide builds up and reacts with trace water vapor to form sulfuric acid clouds. High temperatures and UV radiation. The extreme heat and solar radiation drive complex chemical reactions, maintaining a dense, sulfur-rich atmosphere. Now, what are the effects of sulfuric acid on Venus? Well, you got some really bad stuff. Acidic rain. Although it doesn't reach the surface, sulfuric acid condenses into droplets and falls as rain. But because of the intense heat below, it evaporates before reaching the surface, creating a constant cycle. Extremely hostile environment. The presence of sulfuric acid makes Venus's atmosphere corrosive, making it extremely difficult for spacecraft to survive for long durations. Reflective clouds. The acid clouds contribute to Venus's high albedo, or reflectivity, making it one of the brightest objects in Earth's sky. Despite its harsh conditions, some scientists speculate that microbial life could exist in the upper cloud layers, where temperatures and pressures are more Earth-like. The discovery of phosphine gas in 2020 sparked debate over whether Venus's clouds could harbor some form of life. We will get to that later, however. Another interesting feature is its rotation. Venus spins in the opposite direction of most planets, including Earth. So, if you were standing on Venus, you'd see the sun rise in the west and set on the east, opposite to Earth. Venus also lacks a magnetic field, which is another major difference from Earth. This means its atmosphere is directly exposed to solar wind, which has played a big role in shaping the planet's extreme conditions. On Earth, our magnetic field is responsible for the aurora borealis that many people see closer to the North and South Pole. Now, let's talk about our first attempts to explore Venus. The first missions to Venus started in the late 1950s and early 60s, at the height of the space race between the United States and the Soviet Union. The first spacecraft to ever attempt a mission to Venus was the Soviet Union's Venera 1 in 1961, but it lost contact before it reached the planet. A year later, NASA launched Mariner 2, which became the first spacecraft to successfully fly by Venus. Mariner 2 confirmed that Venus was extremely hot and had very strong winds, shattering the idea that Venus might have been Earth-like. The first spacecraft to successfully land on Venus was the Soviet Union's Venera 7 in 1970. It made the first human-made object to ever land on another planet and send back data. Venera 7 transmitted signals for 23 minutes before it was destroyed by Venus's extreme heat and pressure. But in those 23 minutes, it confirmed just how harsh Venus's surface truly is. 900 degrees Fahrenheit and an atmospheric pressure over 90 times that of Earth, enough to crush a nuclear submarine. The US sent several missions to Venus through the Mariner and the Pioneer programs. Mariner 10 was the first spacecraft to use a gravity assist, swinging by Venus on its way to Mercury. A gravity assist, also known as a gravitational slingshot, is a maneuver used in spaceflight where a spacecraft uses the gravity of another planet or another celestial body to gain speed and change its trajectory without using additional fuel. By flying close to a planet, the spacecraft is essentially pulled by the planet's gravity, gaining kinetic energy from the planet's motion and increasing its velocity as it slingshots around. The Mariner 10 mission, which was launched by NASA in 1973, used a gravity assist from Venus to reach its destination, Mercury. The spacecraft was initially intended to fly by Mercury, but due to its trajectory and the limited amount of fuel available, it required a gravity assist to change its orbit. By flying past Venus, Mariner 10 gained enough velocity to enter an orbit around Mercury. The Pioneer Venus missions in the late 1970s provided a wealth of data on Venus's atmosphere and mapped much of its surface using radar. The biggest success for NASA came with the Magellan mission in 1989.
May 4th, 1989.
Atlantis, Houston, everything down here looks real good to us.
The 5-person crew of Atlantis prepares for the first deployment of a planetary spacecraft from the space shuttle.
Now looking at the business end of the inertial upper stage Magellan stack. This is the nozzle for the solid rocket motor.
Atlantis, Houston, Sunnyvale had a good direct check and their command is complete.
Okay, Pierre, we copy. We're proceeding into the IUSPI lock checkout.
Roger that.
A little more than 6 hours after launch, Magellan and its inertial upper stage booster are released from Atlantis' payload bay to begin Magellan's voyage to peel back the layers of the planet Venus.
Magellan used radar to map 98% of Venus's surface in high detail, revealing mountains, volcanoes, and evidence of ancient lava flows. Then came the Russians. The Soviet Union dominated Venus exploration in the 60s and the 70s. The Venera program alone sent over a dozen probes to the planet. Venera 9 and Venera 10 sent back the first images of Venus' surface in 1975. Then, the later missions, Venera 13 and 14, changed everything. Venera 13 and 14 were some of the most impressive missions ever sent to Venus. Launched in 1981, they landed on Venus in 1982 and became the first probes to send back color images of the Venusian surfaces. The cameras captured the rocky terrain and the thick orange sky. Not only that, but they recorded the first ever sounds from another planet. The microphones picked up the eerie winds of Venus, something no human had ever heard before. Venera 13 lasted for about 127 minutes before it was destroyed, while Venera 14 survived for 57 minutes. These missions provided invaluable data about the planet's surface, composition, weather, and atmospheric conditions. NASA is now planning 2 new missions to Venus, Da Vinci and Veritas. Da Vinci will study Venus's atmosphere in detail, while Veritas will create high-resolution maps of the planet. These 2 will work in tandem to see if there is evidence of a past history of oceans or even life on the surface of Venus. The Da Vinci probe, the piece I am most interested in, is designed to study Venus's atmosphere and surface in unprecedented detail. It will not land on the surface itself, but instead it will release a descent sphere called the Da Vinci Descent Probe that will plunge through the thick atmosphere, measuring the chemical composition, temperature, pressure, and cloud properties as it falls. As it descends, the probe will collect data on the atmosphere, including key gases, which will help determine whether Venus ever had oceans and if it might have supported life in the past. The probe will use a suite of scientific instruments to gather these measurements. The descent probe is expected to survive for about an hour after entering Venus's atmosphere. While this may sound short, it's a crucial window to collect data, as the probe will be subjected to extreme temperatures up to 900 degrees Fahrenheit and crushing pressures. After completing its mission, the probe will likely be destroyed by these harsh conditions before reaching the surface. But in that brief time, it will provide valuable insights into the Venusian environment. If we're lucky, it may outlive one of the Russian probes. Now, one of the most exciting discoveries on Venus in recent years is the detection of phosphine gas in its atmosphere. Phosphine is a chemical compound that on Earth is primarily produced by biological processes, specifically by certain types of microbes. This has led scientists to wonder, could there be life on Venus? While researchers aren't claiming that life has been confirmed on Venus, the discovery of phosphine raises the intriguing possibility that microbes could exist in the planet's upper atmosphere, where conditions might be more hospitable compared to the scorching surface. Venus has an incredibly harsh environment with temperatures hot enough to melt lead, but the upper atmosphere is cooler, with cloud layers that could potentially harbor microbial life. This discovery has sparked new interest in Venus, positioning the planet as one of the hottest targets for future exploration. Scientists now want to learn more. More research and more missions are needed to fully understand the presence of phosphine and what it might mean for the possibility of life. The Da Vinci and Veritas missions, along with other future progress, will be key in helping us answer these critical questions on Venus. Venus is an incredible world, a planet that could have once been like Earth, but evolved into a scorching, inhospitable world. It's been the target of some of the most ambitious space missions in history, and now with new missions on the horizon, we may be closer than ever to unlocking its secrets. Thank you for tuning into the Zach Moore Podcast. If you enjoyed this deep dive into Venus, don't forget to like, subscribe, and leave a comment. What do you think about Venus? Could life exist there? Let me know below. Until next time, keep looking up. And thank you so much for Studio 77 for being the sponsor of this video and also for allowing me to use their services.